In the previous video, we covered the first lab in the SQL injection module. So we got some hands-on experience by exploiting a SQL injection in the search functionality of the application that eventually allowed us to view products that were not released to the public. I've added the link to the previous video in the description if you want to check it out. Now in today's video, we'll be covering lab number 2 of the SQL injection module. This lab will show us how to exploit a SQL injection vulnerability in order to bypass authentication. All right, let's get started. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswagger.net/websecurity and clicking on the sign up button. Now I'm already logged in. So in order to access the Academy, I'm going to click on Academy, scroll down, click on the learning path, select the first one, which is SQL injection, and then jump to the second lab, which is titled SQL Injection Vulnerability Allowing Login Bypass. Okay, so let's look at the description of the lab. So it says this lab contains the SQL injection vulnerability in the login functionality. All right, so we've got a SQL injection vulnerability, and it's in the login functionality. To solve the lab, perform a SQL injection attack that logs into the application as the administrator user. So the end goal is to perform a SQL injection attack and log in as the administrator user. Okay, so let's access the lab. This might take a few seconds. In the meantime, we'll create our analysis section. Okay, so it looks like it's a shopping application which allows you to log in. So let's click on login over here. And based on the exercise, this login functionality is vulnerable to a SQL injection attack. So let's try admin. So it's just maybe a default username password or a common username password, and click on login. And we get the error invalid username or password. So this is what we call a non-verbose generic error message. And it's always good to use a non-verbose one when it comes to functionality like this one. And the reason is because if you said that the username was invalid, that means the attacker would be able to enumerate usernames on the system. And so that's a vulnerability on its own. However, in this application, it actually takes that into account, because if we put just a random username and again a random password, it doesn't actually tell us which one of the input vectors is invalid. Although we know for sure that that was an invalid username because we just put random characters there. Okay, perfect. All right, so let's try exploiting this SQL injection vulnerability. So let's put a SQL character into the username field and see how the application reacts. And I'm just going to put anything in the password field and click login. All right, so this gives us an internal server error, which means something happened at the backend that broke the application. And so this is a good indication that this is vulnerable to a SQL injection. We are not given, just unlike the previous exercise, we are not given the SQL query, so we're going to have to figure it out by fuzzing the application. However, before we do that, since this is a login functionality, chances are that SQL query is something similar to this. So select a certain number of rows from a table. So let's say it outputs the first name from the table, say users, and then where username would be equal to the username that we give it. So remember over here, the first thing that we did was admin. So username is equal to admin, and password is equal to admin. So it's likely that the query at the backend is something similar to this. Now, it will be probably different because passwords are not, or it's unusual that passwords are stored in clear text anymore, so there must be a hashing functionality over here. But what we're trying to do with the SQL injection is put in SQL characters into the username field in order to get the application to ignore ever checking the password. So it doesn't matter if the password is hashed or not. Anyways, so this is likely to be what the query is at the backend. And so let's try and figure out how we could exploit it. All right, so when we put a quote character over here, we got an internal server error. And the reason behind that is because this quote character interfered with the query. So what happens is it closed the single quote over here, and now you were left with a single quote on its own and a bunch of the rest of the query string. And so it likely threw a syntax error, which resulted in an internal server error at the application. And so what we're going to try to do is log in as a user and have it ignore the password field. So let's go back here. Now, if I want to log in as the admin user and I wanted to ignore the password, what I can do is add the comment characters in SQL. And what that means is ignore the rest of the query. So when this gets processed, the query that it'll process is this one over here. Select first name from users where the username is equal to admin. And if the username is equal to admin, then it'll log myself in and it'll ignore the password completely. So let's try that out. And that won't work, and we'll see why in a bit. So password could be anything random. It doesn't matter because it'll get ignored over here. And we click login. And we still get an invalid username and password error. And the reason behind that is because the admin user is not actually a user in the system. So what it's doing is it checks, it wants me to log in as the user where the username is equal to admin, but admin is not a user in the system, and so I don't get logged in. Now we know from the exercise description that the user that we want to log into is the administrator user. So let's use that. That's a user on the system. And we copy our payload. And then again, the password could be anything because it gets ignored. And hit login. And here we go. We got redirected, and you could see you're logged in because you have a logout button to log out from the administrator user's account. And you can see it says, congratulations, you've solved the lab. Okay, perfect. So we successfully completed the exercise by manually exploiting a SQL flaw in the authentication component of the application. Now, the next thing to do, first let's save this. The next thing to do is to script our attack vector. And if you're new to the channel and wondering why I'm scripting it, it's because in your pen testing career, you're going to come across certain attack vectors that require you to script them because it becomes unrealistic in order to do them by hand. And that's why I script all my attack vectors so that I'm prepared when a situation like that happens. And we'll see that in some of the SQL injection exercises where you have a blind SQL injection and you need to run a bunch of requests to the application in order to be able to extract information from the backend database. Okay, so the first thing that I do, since I'm using Python, I'm going to import the request library, and that library will be your best friend when it comes to web applications. And the reason behind that is because it'll allow you to easily make get and post requests and so on to the application. The next thing I'm going to do is import the sys library. And the URL lib3. Okay, I'm also going to set the proxy setting so that the script sends all my requests to burp proxy, and we'll see that in a bit. Okay, so we've got our configuration set. Now let's create the main method. And I'm using Python 3. If the syntax seems a little bit off to you, it's because Python 2 got deprecated. And so I try to use it. I try not to use it as much as possible. Okay, we have a try and catch, try and accept clause. Okay, so what I want is to be able to run my script. So let's say script.py and give it two parameters. The first one being the URL of the application, and the second is my SQL payload. And so in my try and accept clause, the first thing that I'm going to take from the command line is the first argument, which is going to be the URL. So sys.argv one.strip, which strips all the white spaces. You don't necessarily have to do that. And then the SQLi payload is the second argument. Okay. Now, if for some reason I give it an incorrect number of arguments, I don't want it to output the exception or the error. Instead, I want it to output a message. And so I'm going to catch the exception and have it instead display this string over here, which is just the usage instructions. Because most of the time I don't want to go back and look at my script to see what it does. So I just run it without any arguments. And so it'll throw this exception, which will instead output the usage instructions and an example of the usage instructions. So URL, SQL payload. And then the name of the program. That looks good. And then we also output an example, just in case the usage instructions was not clear. An example URL is, let's say, www.example.com. And for SQL payload, let's say 1 is equal to 1. Okay. Okay, that looks good. I think I have an error here. That should be double equal sign. Let's save that and let's run it. So terminal, new terminal. And the name of the program is Python 3 SQLi lab 02.py. So I'm running it with no arguments right now. And I hit enter. That's good. We're not getting any errors, so there isn't any errors in the program. But you'll see over here because we're missing. Here we go. You'll see over here because I didn't enter the correct number of arguments in the command line, it outputted the usage and the example instructions instead of an error that's not going to look too good in our script. Okay, perfect. So that's working well. Next thing to do is actually write the function that will make the requests for us. So to do that, the first thing I'm going to do is use the session object from the requests library. And that's because it allows me to persist certain parameters across the session, and we'll need that for this exercise as opposed to just sending a new request every time. I actually need the cookie to be the same. I need certain parameters to be passed along, and that's why I'm using the sessions object. Next, I'm going to create a function called exploit SQLi. And if it evaluates to true, so I'm going to pass the session object there, the URL, and the SQLi payload. If it evaluates to true, then our SQL injection was successful. So say SQL injection successful. We have logged in as the administrator user. However, if it evaluates to false, then I want to print SQL injection unsuccessful. Okay. Again, let's save that. Okay, so just to recap, what's happening over here is it takes in the first command line argument, it sets it to the parameter URL, it then takes in the second command line argument and it sets it to the parameter SQLI payload. We create a session object from the request library, and then we pass the session object, the URL, and the SQLI payload into a function called exploit SQLI, which we'll write in a bit. And if that function evaluates to true, that means our SQL injection was successful. If it evaluates to false, that means our SQL injection was unsuccessful. So let's start writing the function. Exploit SQLI, and again, takes the session object, the URL, and the payload. And for now, our function does nothing, because we don't actually know what type of requests are being made in the application. So to do that, we need to use our favorite proxy tool, which is Burp Suite. Let's click OK. And if you've never used it before, what this is, it's pretty much a middleman in between your browser and the application. And so any requests that the script makes or that the browser makes first go through Burp and then get passed to the application. And any responses from the application itself go through Burp again before they're passed to your script or your browser. So let's see that over here. I'm going to click log out. If you look at the options over here, it's set at localhost 8080, which is why I use that configuration in the proxy setting in my script. And this is taking a while. It might have timed out. So what we're going to do is we're going to create a new instance of the lab. Here we go. All right. In order for the browser to send all the requests to Burp, we need to configure it to do that. And in order to do that, what I use is an extension called Foxy Proxy, and I have Burp set as one of my options. And now what it'll do is it'll send all the requests to Burp before it actually gets sent to the application itself. And you could see that by clicking on the login button. The request is intercepted over here, and now it's just waiting for me to forward that request. So what I'm going to do is send this to repeater and hit forward. And now it forwarded the request. Hit forward again, and I'm just going to send the intercept to be off. So if you go to repeater and hit send, you could see that the response, that this is the response over here. And now let's go back to the proxy HTTP history that logs in all your requests. If you hit the login button, it makes a request to /login over here. So let's look at that. So it makes a request to login, and this is the response. And then when I hit admin, and I click login, it makes a post request over here. And notice that it uses the parameters CSRF, username, and password. So this CSRF token is something that we should test out. So I'm going to send this to repeater. And let's look at it. So I'm going to put this over here because this will be something that we need to analyze for our script. So I want to make sure that the CSRF token is actually being used by the application. And this is useful if you're testing applications in general to see if it's implemented correctly. So the first thing that I'm going to test is I'm going to remove it and see if the application actually cares that there's a CSRF token. If it doesn't, we should get like a 200 response. But in this case, you get a 400 response code and it says that CSRF token is missing. So we do definitely need one. Now let's see if I can use a random one. So let's say this and hit send. So it's telling me that this is an invalid CSRF token. Again, this is good. That means it's implemented correctly. So what that means, let me just go back. What that means is that this token is being saved at the backend and it's associated to this session. And this is why when we make multiple requests, because we're going to have to first make a GET request to the login page and then a POST request in the login page. This is why it was necessary for us to use the sessions object over here, because if we just made the requests themselves, the cookies and the parameters will not persist across the session. And so over here, for me to make the login request, I need 3 values. The first being the CSRF token, the second being the username, and then the password. So to get the CSRF token, I needed to make a request to the login page. So to do that, I'm going to create a new function called getCSRF token, and it takes in the session object and the URL. I'm going to say incomplete. And the next thing I'm going to do is implement this function. Okay, this URL. Okay, so to make the first GET request to the login page, which is what we saw, we go to proxy over here, this request over here. So it makes it to the login path. So let's use session object to do that, .get, and it takes in the URL, verify is equal to false. I don't want to verify any TLS certificates, and proxies is equal to proxies. And again, what that means is that this GET request, when it makes it, it'll pass through my proxy, and that would be very useful in case it doesn't work. This way, I can see what requests the script was making and the response that I got from that request. Okay. Now, when it makes that GET request, I need to be able to parse this response in order to get the CSRF token from it. So if you do CSRF over here, you'll see it's in an input, what is it called? An input element. And it's a value field that has the CSRF token in it. So I need to be able to parse that response in order to get the CSRF token from there. So to do that, I'm going to import one more library. And it's called Beautiful Soup. And then I'm going to set it over here. R.text, so the response text. And set it at HTML parser. Okay. So now the CSRF token is in the first input element, and grab the value field. Okay. So this will search the response code over here, take the first input element, and then take the string that is that the value field is equal to. And so let's test this out. I'm going to click save, and let's just say print CSRF and see if it actually prints it out. Let's clear this. And the URL is this one over here. And again, I don't care what the SQL injection is. Let's just say admin and hit enter. Okay, so we get an error. And it's on line number 22. And we spelled that wrong. That's why. Okay, clear. Run the same command. And we get a warning. So I want to suppress this warning because I don't want to see it every time it makes a request. And the way you could do that is using this line of code over here. And secure request warning. Okay, let's clear. Okay, here we go. So it suppressed the warning, and you could see over here that it printed out the CSRF token. So let's see if that is exactly the case, because I have my proxy settings set to send all my requests to Burp. We should be able to see it. So this is the login request that was made, and if you look for CSRF, you'll see that's the value that it pulled from over here. Okay, awesome. So now we have the CSRF token. Instead of printing it, I'm going to return it. This way, when we call the function, it'll return the CSRF token and it'll save it in the variable called CSRF. So the next thing to do is to make a post request to the login functionality. So if we look at the post request over here, it takes in the CSRF token, it takes in the username, and it takes in the password. And so we'll put URL, data is equal to data. So that parameter has to include all these variables over here. We'll set it in a second. Verify is equal to false. I don't want to verify TLS certificates. And proxies is equal to proxies. Because again, I wanted to always pass the request to my to the Burp proxy just in case I need to debug it. All right, for data, let's instantiate that. First, we use the CSRF token. And we'll learn in the upcoming modules what the type of attack that the CSRF token, which is known as cross-site request forgery, so the type of attack that it defends against. Username. Over here, that would be our payload, because that's the field that we're exploiting the SQL injection in. And then password. That could be anything, so I'm just going to say random text. Okay. All right, perfect. Over here, we're making the post request. And then right now, what I need to do is, if I'm logged in, I need a way to figure out that I am logged in. So I'm going to set the response of the request in the parameter res. And if the string log out is in the response, then I know that I successfully logged in. So I'm going to return true. Else, return false. Okay, so let's explain this portion over here. Let's go back to the application. I don't actually know a valid username, a valid credentials, so username and password. So I'm just going to exploit the SQL injection again to log in. Once we're logged in, we get displayed with a logout button. And that's why, in order to figure out if my SQL injection was successful or was successfully exploited, then I check for the logout button in the response. If it's there, that means I've logged in as the administrator user, and so it returns true. Otherwise, it returns false. Okay, so let's look at the script one more time before we run it. So if we go back over here, it first takes in the first parameter from the command line. It sets it to URL. Takes in the second parameter, which is the SQL injection payload, and it sets it to this parameter over here. It starts a session object, and then it calls the exploit SQLi function. If that function evaluates to true, then it says SQL injection is successful. Otherwise, if it evaluates to false, then it says it's unsuccessful. Now, in the function itself, the first thing that the function does is it gets the CSRF token from the response, and then it uses that CSRF token to make a login request using the token itself, and then the payload in the username field, so the SQL payload, and any password. It makes the post request over here. It checks the response to see if the response has logout in it. If it does have the string logout in it, then it returns to true. Otherwise, it returns to false. And that's kind of a recap of what the script does. So let's clear this and run this again. So just putting admin in here, right? So if we log out, that should say that the SQL injection was unsuccessful because we don't actually log in. And I'm not sure the URL is the same, so I'm just going to copy it one more time. Okay, hit enter. And it says it's unsuccessful, which is the behavior that we expected. This is good. So let's clear one more time and try a true case. So one that would be successful. Administrator. And then come out the rest and hit enter. Here we go. And it says SQL injection successful. We have logged in as the administrator user. And if you go to burp over here, you'll see that it made a post request. This is the CSRF token that we got. This is the SQL payload that we entered in the script. And this is the password, which is random text over here. And then the response was at 3:02. Since we are using the session object, it followed the redirect, and it made the GET request with the same session cookie, and the response was a valid logged in response because we could see the logout string over here. Okay, awesome. So we've completed the exercise. To recap, in the video, we first manually exploited a SQL flaw in the authentication component of the application. This allowed us to log in as the administrator user without actually knowing the administrator's password. We then scripted the exploit so that it automatically does that for us.